All right, 4.7, order of operations and complex numbers. And that should be complex fractions, not complex numbers. All right. So we have 2/5 squared. Let me erase some of this so we can walk through it. So if we have 2/5 squared, you're going to square the top and the bottom individually. So that would be 2 squared and 5 squared down bottom. And 2 times 2 is 4, and 5 times 5 is 25. So that's how we get 4/25. Now comparing the next two, we're talking about negative 2/5 squared using parentheses versus negative 2/5 squared not using parentheses. We have to be careful here, is because when we're using parentheses, that means we want to include the negative as a part of being affected by the square. If we don't use the parentheses, the only thing that's being squared is the 2/5. So that means if you don't use parentheses, that negative that's sitting on the outside stays sitting on the outside and is never affected by the square. So that's negative 2/5 times 2/5, and that'll be a negative 4/5. But over here, if you include the negative, that's going to be negative 2/5 times negative 2/5. Negative to a negative turns positive, so we have a positive 4/5. So before we go anywhere with that, make sure we're okay with the idea of including parentheses versus not including parentheses when you have a negative number involved. All right. Down here is negative 1/4 cubed. So there, notice the parentheses are over the negative. So we're going to include the negative as being affected by the cube. But that's negative 1/4 times negative 1/4 times negative 1/4. Two of those negatives will cancel because negative times negative is positive. That still leaves you with 1. And so that negative will still be there. So that's 1 times 1 times 1, which is 1. And then 4 times 4 times 4 is 64. All right. Questions? Any questions?
I have a question.
Mm-hmm.
So when you did the problem, negative 1/4 with the 3 squared, I guess. So did you basically just like take the negative 1 and just square it by 3 and then get negative 1/4? Or
Mm-hmm. Yep. So whenever you're cubing something, you multiply it times itself 3 times. Same thing as if you raise something to the 4th power. If I have 3 to the 4th power, then that's 3 times itself 4 times.
okay.
Yeah. And so yeah, that's what that did. That raised that 3, raised the 1/4 to the 3rd power. So that means that negative 1, you're cubing it or multiplying it times itself 3 times. And the same thing with the 4 down bottom. Anything else before we add a little more to it? All right. So let me erase some of this stuff so we can walk through this. Okay. So we talked about order of operations before, and it's the same thing, same order of operations. PEMDAS, you do what's in parentheses or any grouping symbols first. That's your P. E is your exponents, get your attention next. Multiplication, division, you do those from left to right. Addition and subtraction, do them from left to right. So we have to do what's in the parentheses. Before we look at this square, we have to do what's inside of the parentheses first. So we have negative 2/15 times 3/4. So instead of just multiplying straight across 2 times 3, 15 times 4, what I did was I broke down the 3 times the 5 and the 4, which is 2 times 2, so that I can cancel first. So I can cancel out these 2's, which will leave me a 1 here. Cancel out 3's. That'll leave me a 1 up top as well. So now if I multiply across, negative 1 times 1 is negative 1. And then 5 times 2 is 10. So we have 10 in the bottom. Then we square the top and the bottom. Negative 1 times negative 1 is positive 1. 10 times 10 is 100. All right. Questions on that one? All right. So here we have 1/2 plus 3 3/5 times negative 10 ninths. So what I did was I turned 3 3/5 to an improper fraction first. So that's 3 times 5 times 3. You know, whole number times the denominator plus the numerator. 3 times 5 is 15, plus 3 is 18, so it's 18 over 5. According to PEMDAS, we're going to do multiplication next. And so instead of multiplying 18 times 10 and 5 times 9, I broke down the 18, 10, and 9 first. So 18 is 2 times 9. 10 is 2 times 5. We have a 5 down there already, and I just left that 9 there because the 9 is in the 18. So those 9's cancel. 5's cancel. And down bottom, all we have is 1, so it's 1 times 1. And then up top, 2 times negative 2, which is negative 4. All right, so before I go any further, is everybody all right?
Yeah, I think we're pretty cool.
All right, appreciate that, sir. So now we're looking at finishing off the problem. We have this left, got the 1/2 from the beginning of the problem that we haven't dealt with yet, and that's minus what was left over, which is 4 over 1. So don't forget, whenever adding and subtracting fractions, you need a common denominator, and that is going to be 2 for us. So we'll multiply top and bottom by 2. 1/2 minus 8/2, so 8 over 2 will be negative 7 over 2 as a final answer. So, all right, questions? Any questions? All right, scrolling up, that's fine. Everybody good? All right. Next problem, evaluate. We have 2 divided by y times z, but they give us y to be equal to negative 14 over 3 and z to be negative 1/3. All right, so erase some stuff. All right, so this is what we're looking at right here as far as the setup. Now we plug it in negative 14 over 3 and negative 1/3 where y and then where z is. All right, so we do division and multiplication. We handle them from left to right. So the first thing that we come across is division. So we're going to divide. Don't forget, we're going to multiply by the reciprocal. That means we flip the fraction. So 14 over 3 turns into 3 over 14. All right. So this is what we have now. I'm going to break up that 14 just into 2 times 4. I mean 2 times 7, excuse me. And then cancel out with whatever's in top and bottom. I have all of this is multiplication now. So I can just cancel out anything that I have in common with the top and bottom. So 2's cancel. And then also these 3's cancel. All right. Also, I have a negative here and a negative here. So if I multiply across, all I have is 1's up top, then down bottom, 7 times 1 to give you 7. So my result would be 1 over 7. All right. Somebody in the chat. Let's see. Not a problem. I appreciate your honesty. All right. So let's look at complex fractions. All right. So a couple different ways we can handle complex fractions. Well, there are 2 ways. Basically, the first way is this type of situation where we have one whole, didn't mean to do that. One whole fraction over one whole fraction. This is considered complex because we have one fraction here, one fraction here, and this whole thing is considered a fraction. So we actually have 3 fractions. But what I can do is rewrite this horizontally. So I have 3/5 over 5/10, but I can rewrite it as 3/5 divided by m over 10. Did I say 5/10 meant m over 10, m/10, whatever. Not 5/10. And so that division bar and the division symbol are the same thing. So that's why I can rewrite it. This is written vertically. This one is written horizontally using different symbols but meaning the same thing. But now, if I want to divide, I need to change that to multiplication and flip the fraction. So that's why it flips from m over 10 to 10 over m. Cancel out the 5's that are in common with the top and bottom because 10 has a 5 and then there's a 5 in your denominator. And then 3 times 2 on the top is 6, m on the bottom. All right. Let's look at the other way of dealing with this type of problem. So in this next one, we have 2/5 minus 1/3 over 1 minus 3/5. So notice we don't have a whole fraction right here. We have two fractions, not one single fraction. Same thing down here, we don't have one single fraction. So the best way to handle this problem is to first find the LCD of each one. So we have 5, 3, and 5, and the LCD of all three of those is 15. That's the smallest number that each number can divide into evenly. So don't forget that, smallest. So it's the smallest number that each can divide into, not what can divide into them. All right. So that's 15, and we're going to multiply each numerator by that 15. So let me erase some of this so we can, like I said, walk through it. So notice we multiply each numerator by 15. The denominators are still there. See, 5, 3, and 5 are still there, but we multiply each numerator. Even if it didn't have a fraction at all, that one was still affected by that 15. We multiply each numerator by the LCD. So after you do that, you want to simplify. So 5 will divide into 15 and leave you with 3. 3 will divide into 15, leave you with 5. 5 will divide into 15, leave you with 3. So that'll be 3 times 2, which is 6. 5 times 1 is 5. 15 times 1 is 15. 3 times 3 is 9. 6 minus 5 is 1. 15 minus 9 is 6 for your final answer. Questions? Any questions? All right, so let's do that again. Try it again. We have 3/10 minus 1/2 over 2 plus 1/5. LCD is 10. So we're going to multiply each numerator by 10. So it's 10 times 3 over 10, 10 times 1 over 2, 10 times 2, and then 10 times 1 over 5. All right, so now we can cancel out. 10s cancel, leave you with 1. 2 goes into 10, leaves you with 5. 5 goes into 10, leaves you with 2. So 3 minus 5 over 20 plus 2. Negative 2 over 22. cancel out 2, and that'll leave you with negative 1 over 11. All right, any questions? Okay, that's similar. I should have put, let me do this real quick so I don't forget next time. I should have put a dash up here, 4.8. All right. So everybody good with that before we look into 4.8? That segues us into 4.8. Same type of stuff, except we're going to make it an equation. All right. So 4.8, solving equations containing fractions. And we solve these like we solve other equations without fractions, using your opposite operations, adding in order to undo the subtraction, multiplication in order to undo division, and vice versa. So, let me erase some of the stuff. All right, so we have x minus 3/10 equal to 9/20. I want to solve for x. So I need to get the minus 3/10 to the other side of our equation. Remember, your equation is set up by, the sides of your equation is set up by your equal sign, left side of your equal sign, right side of your equal sign. So in order to cancel out the subtraction of 3/10, I need to add 3/10 to both sides of the equation. All right. 3/10 and negative 3/10 will cancel on the left. On the right, once again, in order to add fractions, you need to find your common denominator. LCD of 10 and 20 is 20. So I'll multiply top and bottom here by 2, excuse me. And it'll be 6 over 10. I said 6 over 10, 6 over 20. Sorry about that. 6 over 20. And then here, this stays the same. 9 over 20. So 9 over 20 plus 6 over 20 is 15 over 20. And of course, you have to reduce that. 15 is 3 over 5. 20 is, I said over 5, 3 times 5. And then 20 is 4 times 5. The 5s cancel, and that'll leave you with 3/4. All right. Any questions? All right. So same thing happens here. We have negative 5/4 equal to 1/2 plus y. So we subtract 1/2 from both sides. So what happens over here? So we subtract 1/2 from both sides. They cancel out on the right, so that I can have this y by itself on the right. Then we have negative 5/4 minus 1/2. You know, in order to add or subtract the fractions, we need that common denominator. which is going to be 4 for us. So I multiply top and bottom by 2 here. And that takes me to negative 5 over 4 plus negative 2 over 4. And that gives us negative 7 over 4. So that's how we got that answer. All right. Questions? Any questions? All right. Here, 4/5 x equal to 2/7. So the way we can take care of this problem is by multiplying by the reciprocal. Multiplying both sides by the reciprocal of what's in front of your x. Remember, your goal is to get x by itself. So you need to remove 4/5 from both sides. So the way you do that is by multiplying both sides by its reciprocal. Remember, reciprocal is just flipping that fraction. So we have 4/5. We multiply both sides by 5/4. So what that does is it allows for 5 over 5 to cancel, 4 over 4 to cancel. That leaves with 1. And that's just 1x right here. On the right side, though, we need to multiply 5 over 4 times 2 over 7. And doing that right here allows us to have the final answer of 5 over 14. Any questions? Any questions? All right, we have a few more. All right, so another option or way of solving equations. Here we have 3/4 x minus 1/3 equal to 5/6. We can do what we call clear out your fractions, in which the first thing you would do is find the LCD of each denominator. We have 4, 3, and 6. The smallest number that they can divide into evenly will be 12. All right. All right, next, you're going to multiply each numerator. Notice I said numerator. Multiply each numerator by the LCD. So it's 12 times 3x over 4, 12 times 1 over 3, 12 times 5 over that 6. All right, now we can simplify. 4 goes into 12 and leaves us with 3. 3 goes into 4, 3 goes into 12, leaves us with 4. And then 6 goes into 12 and leaves us with 2. All right. Now if we simplify, 3 times 3x is 9, 4 times 1 is 4, and 2 times 5 is 10. And so now we have a regular linear equation. And we can go ahead and solve that. So I would add 4 to both sides to cancel out that negative 4. Divide by 9, and my solution is 14 over 9. All right. Any questions? All right. So let's do it again. So we have y over 8 plus 3 over 2 equal to y over 4. And between 8, 2, and 4, our least common denominator is 8. So we multiply each numerator by 8. All right. Divide 8 into 8 leaves you with just 1. 2 into 8 leaves you with 4. And then 4 into 8 leaves you with 2. All right. All right, so that'll leave us with y plus 12 equal to 2y. Now we have y in 2 different places. So we want to get them on the same side of our equal sign. So we can subtract y from both sides. Don't forget y. And that's what I was emphasizing right here. Y means 1y. They assume you know there's a 1 sitting in front of that y. So y minus y will cancel. 2y minus y is 1y. And that's our solution. When y is equal to 12. Questions? Any questions? Concerns or comments? Anything, anybody? All right. So that's 2 sections. That's enough for today. Next class, that's it for chapter 4. So next class, we can look to review, see if you guys have any questions. Make sure you bring your questions to class. I don't have to do any new material. If you guys want to just bring your questions, we can just do them. So I'll open up the floor for questions first and answer whatever it is that you guys got. So I would rather answer questions than do anything new. But of course, you know, sitting around just looking at each other isn't an option as well. So, we got to do something. So make sure you guys bring something to class so we can talk about it and put ourselves in a good position for a review. So outside of that, any questions before I let you guys go? Straight. All right. Well, you guys have a good one. Be safe, and I'll see you on Wednesday.
Thank you.
Thank you. Have a good one.